Here we are going to discuss Pythagorean triples. The Pythagorean theorem, that beloved formula of all high school geometry students, says that the sum of the squares of sides of right angle triangle equals to the square of the hypotenuse. In symbols, you can see simply this is the height, this is the base, and this is hypotenuse. Basically, B and A are two adjacent sides at right angle, and C is the hypotenuse. And here the result is a square plus b square is equal to c square. There are various methods to prove this, and everybody can try to prove this result. A square plus b square is equal to, you can see, c square, where a and b are adjacent sides and c is the hypotenuse. Since we are interested in number theory, that is the theory of natural numbers, we will ask whether there are any Pythagorean triples, all of whose sides are natural numbers. There are many such triangles. The most famous has sides 3, 4 and 5. Here are the first few examples, like 3 square plus 4 square is equal to 5 square, same 5 square plus 12 square is equal to 13 square, 8 square plus 15 square is equal to 17 square, and also 28 square plus 45 square is equal to 53 square. The study of these Pythagorean triples began long before the time of Pythagoras. There are Babylonian tables that contains list of parts of such triples, including quite large ones, indicating that the Babylonians probably had a symmetric method for producing them. Even more amazing is the fact that the Babylonian maybe had practical reasons for studying Pythagorean triples. Do such practical reasons still exist for this particular problem? The answer is probably not, because there is at least one good reason to study Pythagorean triple, and it's the same reason why it is wrong while studying the art of Rembrandt and the music of Beethoven. There is a beauty to the ways in which the number interact with one another. Just there is a beauty in the composition of a painting or symphony. To appreciate this beauty, one has to willing to expand a certain amount of mental energy. So here, recall our checklist. The first step is to accumulate some data. I used a computer to substitute in values of a and b and checked if a square plus b square is a square. Here are some primitive Pythagorean triples that I found: 3, 4, 5, 5, 12, 13, 8, 5, 15, 17, 7, 24, 25, 20, 21, 29, 9, 40, 41, 12, 35, 37, 11, 60, 61, 28, 45, 53, 33, 55, 56, 65, 16, 63, 65. A few conclusions can easily be drawn even from such a short list. For example, it certainly looks like one of A and B is odd and the other is even. It also seems that C is always odd, like here you can see 3 and 5 both are odd, 4 is even. Also 5 and 13 are odd, 12 is even. Same here, 15, 17 are odd and 8 is even. Same here, 24 is even, 7, 25 is odd, 20, 20 is even, 21 and 29 are odd. Same here, 9 and 41 are odd. Same here, 12 is even, and 35 and 37 are odd numbers. Same here, 11, 60, 61. 60 is an even number, but 11 and 61 are odd numbers. Same here for 28, 45, 53, 33, 56, 55, and 16, 63, 65. A few conclusions that can be easily drawn even from such a short list. For example,